Good evening. Today we will have the live session for structure, form and architecture, the synergy. Week 4, assignment 4. We will wait in the meeting for 5 minutes for others to join, and then we will start the live session. I will start with the session. So, welcome to the live session for Structure, Form and Architecture, the Synergy. The course instructor is Professor Shubhajit Sadhukan from IIT Roorkee, and I am Shreya Shukla. I am currently pursuing PhD at IIT Roorkee, and I am the NPTEL TA for this course. Today we will be doing assignment 4 for week 4, and in these live sessions we only do previous year questions. We do not do this year's question. So without any further ado, I will start. So structure, form, architecture and synergy, the 4 terms in the name of the course. I explain these terms in every class, and I'll quickly define these terms before starting the session again. So structure has a lot of meanings in different contexts, but in terms of architecture, it refers to the system which is used to support and transmit possible loads on the building to the ground. It gives stability, it resists stresses and strains. Form, in terms of architecture, a form is a three-dimensional object or building that is perceived by a viewer in space and time and made possible by the action of light and shadow. Architecture is the art and technique of designing and building. Synergy, the interaction or cooperation of two or more organizations, substances or other agents to produce a combined effect greater than the sum of their separate effects. So week 4 syllabus was structural typology. 5 lectures. First was structural typology, compressive. Second was compressive structures. Third, tensile structures. Fourth, load bearing structures, and fifth, temporary structures, in which scaffolding and raking was covered. Without any further ado, we will start with the questions of assignment 4. Which of the following statement is true for plain cement concrete structure? Plain cement concrete is poor in compression but good in tension. Plain cement concrete is good in compression but poor in tension. Plain cement concrete is good both in compression and tension. Plain cement concrete is poor both in compression and tension. So what is plain cement concrete? Plain concrete, also known as plain cement concrete or PCC, it is most commonly used for paving and flooring. PCC is made up of 3 basic components: water, aggregate, which is rock, sand or gravel, and cement. Cement, usually in powder form, acts as a binding agent when mixed with water and aggregates. The different type of aggregates and ratio of materials used will give different types of cement with slightly different properties. Plain concrete is a brittle material with low tensile strain and strength capacities. PCC is incredibly strong under compression. PCC is incredibly strong under compression whilst weak under tension. This means that when on a solid unmoving surface, it is capable of withstanding huge amounts of weight. However, when it is placed under tension, it is much weaker and can often crack and buckle. This makes it the perfect material for ground floor layers and providing stable and even base for reinforced concrete to be built onto while limiting its use in larger construction projects. So what happens in PCC is that it has incredible compressive strength, which means that if load is put on the PCC, it would be able to handle that load. But if PCC is put under tension, which means that it's being stretched apart, it will buckle and crack. So it is weak under tension. So which makes it a great layer for ground floor layers and providing a stable base for RCC. But it also, because it has limited because of bad tension, its inability to withstand tension, it is not that great just to use as PCC in larger projects. So this is another image which shows that a beam or wall, while a load is put on it, it experiences So when a load is put on a beam of, imagine, let's say it's concrete, it's plain cement concrete PCC. So you see that deflection occurs when a load is put, and the concrete in tension, it causes cracks, while the concrete, because of compression, it only buckles from top. So the question was, which of the following statements is true from plain cement concrete structure? And the answer is that plain cement concrete is good in compression, but it is poor in tension. So it has good compressive strength, it can take load, but it has bad tension. It is bad under tension, which means that if concrete is pulled apart, in any case, the load that pulls it apart, it will crack and it will break. It becomes brittle that way. Question number 2. Name the following structural form. So this image has been provided of a vault, and you are asked to identify which vault is this: ribbed vault, barrel vault, groin vault, or Nubian vault. So ribbed vault. In a ribbed vault, a ribbed vault is an architectural feature comprising of a framework of crossed or diagonal arches, ribs, or you can say the skeleton of arches or ribs, on which the masonry can be laid out to form a ceiling. And variations of ribbed vault were used in Roman architecture, Byzantine architecture, Islamic architecture, Romanesque architecture, and especially Gothic architecture. Then barrel vault, also known as tunnel vault, wagon vault, or wagon head vault, it's an architectural element formed by the extrusion of a single curve along a given distance. So barrel vault is basically one arch which is repeated, or one arch that has been stretched for a length. So it creates a barrel-like structure or a semicircular kind of structure. The curves are typically circular in shape, and which leads to a semi-cylindrical appearance to the total design. Then groin vault. A groin vault or a groined vault is produced by the intersection at the right angles of two barrel vaults. So when two barrel vaults, imagine two semi-cylindrical vaults, if they are put at intersection with each other. So when that intersection is formed, so the shape that generates by the intersection of at right angle of two barrel walls is a groin vault. Groin refers to the edge between the intersecting walls. Sometimes the arches of groin walls are pointed instead of round. Groin wall construction was first exploited by the Romans, and it is difficult to construct neatly because of the geometry of the cross groins. Then Nubian vault. A Nubian vault is a type of curved surface forming a vaulted structure. The mud brick structure was revived by Egyptian architect Hassan Fadi. The technology is advocated as environmental friendly and sustainable since it makes use of pure earth without the need of timber. One of the key advantages of Nubian vault is that it can be built without any support or shuttering. The earth bricks are laid leaning at a slight slope against the gable walls in lengthwise vault. So now just adding all the four images here. This is a barrel vault, that is a groin vault, and this is a rib vault. And this is a cross section of a Nubian vault. So coming back to our question, name the following structural form. So this is a groin vault. Question number 3. Dome develops dash along its meridian. Bending stresses, compressive stresses, tensile stresses, both compressive and tensile stresses. So in domes, there are two types of forces that occur: meridional forces or hoop forces. Meridional forces, hoop forces are the concentric circles from the base of the dome to the top of the dome, and the meridional forces are the meridians coming from the center to the base of the dome. So domes are self-supporting structures, and they take the form of an arch distributing external loads around the sides and down to the foundations. They are tightly compacted by gravity, and external loads are carried by the compressive forces that develop internally. The analysis of a dome shell is concerned with two stresses: the stress that acts in the meridional direction and the stress that acts in the parallel direction, or hoop. So hoops are parallel semicircles from the base of the dome to the top of the dome, and meridional forces are from the top of the dome to the base of the dome, running in the longitudinal form. So in this image, the red marks the meridional compressive force, and dark blue marks the hoop compressive force, and light blue marks the hoop tensile forces. So answer is that dome develops compressive stresses along its meridians. So in the case of a dome, compressive stresses are developed along the meridians, but along the hoops, or you can say the parallel circles to the base of the dome, along the hoops, both compressive and tensile stresses are developed. Question number 4. The ability of a material to prevent structure against pulling load is referred as compression, tension, shear, or torsion. The ability of a material to prevent structure against pulling load. So, uh, definitions, we'll go to the definitions. Compression force or compressive force. It occurs when a physical force presses inward on an object, causing it to become compacted. In this process, the relative positions of atoms and molecules of the object change. This change can be temporary or permanent depending on the type of material receiving the compressive force. So compressive force is when you push it together. When this push inward force is being applied inwards on an object. Shear force is a force acting in a direction that's parallel to or over the top of a surface or cross section of a body, like the pressure of airflow over an airplane wing. The word shear in the term is a reference to the fact that such a force can cut or shear through the surface or object under strain. Then tension. Tension is described as pulling force. It's a pulling force. It's a force that is pulling the object. Excuse me. Transmitted axially by the means of a string, a rope, chain, or similar object, or by each end of a rod, truss member, or similar three-dimensional object. Tension might also be described as an action-reaction pair of forces acting at each end of said elements. Then torsion. If a torsion load is applied to a material, it will create shear stress which induces torsional force. So if this force is large enough, it can cause the material to twist. So in torsion, the material twists because of the force that is being applied on an object. It can cause shear, and which sometimes induces torsional force, which creates the object to twist. So this twisting force is called torsional force. So examples here of some examples over here. So in tension stress, the object is pulled apart and it breaks. In compression stress, the object is pushed apart and it breaks. In shear stress, it can shear. And a few more examples of compression and tension and torsion. And this is a image that explains the all four types of forces very clearly: tension, compression, shear, and torsion. In tension, the object elongates. In compression, the object compacts. In shear, the object shears or divides. In torsion, the object twists. So our answer is the ability of a material to prevent the structure against pulling load is referred to as tension. So यहाँ पे, so here we are talking about pulling load. So a material which can prevent the structure in breaking against a pulling load is the tension. So like we discussed in previous question, concrete or PCC has bad tensile strength. Like if a pulling load is applied on it, it has a bad tensile strength, it will brittle or it will create cracks. However, it has good compressive strength that if it is pushed together, it will be able to take up that load. Question number 5. The McCormick Place in Illinois is an example of trussed tensile structure, pneumatic tensile structure, cable suspended tensile structure, or stage tensile structure. So this is what McCormick Place in Illinois looks like. It is the largest convention center in North America. It consists of 4 interconnected buildings and 1 indoor arena. It is near Lake Michigan in Illinois, United States. The architect is Gene Summers and the owner is Metropolitan Pier and Exposition Authority. Excuse me. It was opened in 1912 and the height is 96 meters. So what is a trussed tensile structure? Truss is a structure that consists of members organized into connected triangles so that the overall assembly behaves as a single object. Trusses are most commonly used in bridges, roofs, and towers. A truss is made up of a web of triangles joined together to enable the even distribution of weight and the handling of changing tension and compression without bending or shearing. So a truss is nothing but it is a web of different triangles joined together so that you can create an even distribution of weight, and it so that the structure can handle the change of tension and compression without bending or shearing. A pneumatic tensile structure. So, pneumatic structures are membrane structures comprised of the volume of inflated air. They are extremely lightweight structures, and an existing internal pressure pre-stresses the envelope membranes that are subjected to tension and counteracts the external loads. The membranes usually consist of ETFE foils. It is stabilized by the pressure of compressed air. Air supported structures are supported by internal air pressure, and a network of cables stiffens the fabric, and the assembly is supported by a rigid ring at the end. So what happens in pneumatic structure is that it's a volume of inflated air. So they are extremely lightweight structures, and we have external this structure is maintained by creating a pressure by internal air pressure. So this is it's a fabric usually made of ETFE foil, and it is created in this shape, or the shape is maintained by internal air pressure, and they are membrane structures, and that's why they are tensile structures. Cable suspended tensile structures. The main pillars act as compression members, but the whole load is carried out by the cables, which are in tension. A suspended structure is a structure which is supported by cables coming from beams or trusses which sit atop a concrete center column or core. The design allows the walls, roofs, and cantilevered floors to be supported entirely by cables and the center column. So what happens in cable suspended tensile structure is that the main cables or the main pillars, they are compression members, and the whole load is carried out by the cables which are coming from the compression member or the compression column to the structure. For example, in bridges, it's a suspended structure which is supported by cables coming from beam or trusses which sit atop a concrete center column or core. So there would be one column or a core of concrete, and these cables come out of that structure, and then they support the base or wall. The design of this kind of structure, it allows the walls, roof, and cantilevered floors to be supported entirely by cables and a center column. So there is a center column, and the entire load, you can say, or the entire floor, you can say, is supported by the cables. The cables have tensile strength in them which support the whole load, while the pillar only has compressive strength. Stayed tensile structure. In this structure, the whole mass of the roof and other things are being supported by the stayed cables. The tension members are supported by the compression members, but major loads are carried out by the tensile members. So our answer is that McCormick Place in Illinois is an example of stayed tensile structure. Which of the following is an example of cable suspended tensile structure? Signature Bridge, Delhi, Howrah Bridge, Kolkata, Mahatma Gandhi Setu, Patna, Pamban Bridge, Mandapam. So this is the image of all four bridges: Signature Bridge, Delhi, Howrah Bridge, Kolkata, Mahatma Gandhi Setu, Patna, and Pamban Bridge, Mandapam. So as we mentioned earlier, that in cable suspended tensile structures, the main pillars act as compression members, but the whole load is carried out by the cables which are in tension. And a suspended structure is a structure which is supported by cables coming from beams or trusses which sit atop a concrete center or column or core. The design allows the walls, roofs, and cantilever floors to be supported entirely by cables and a center column. So it's evident when we go back to these images, it's evident that the Signature Bridge, Delhi, is a cable suspended tensile structure. and not the others, because Havra Bridge and the Pampam Bridge are trusses, and the Mahatma Gandhi Setu looks like it's built out of concrete or masonry. So the answer is Signature Bridge, Delhi. Uh, then which type of load bearing structure is shown below? So one image has been given and you are asked to identify which kind of load bearing structure is this, and the options are cellular wall structure, single cross wall structure, double cross wall structure, or complex cross wall structure. So in a cellular wall structure, what happens is that the external walls form the boundaries of the building and the internal walls are used to divide the space. They are connected as shown in the figure to form a cellular wall arrangement. All the walls are load bearings or structural walls. So in cellular wall structures, all the walls are load bearing walls. And in simple cross walls, it is usually used for many identical rooms can be constructed together, and there are openings provided on the walls, and these openings in load bearings affect the load carrying capacity of the wall, and thus in the case of a load bearing structure it is advised to provide fewer smaller openings. So what happens in simple cross wall structure is that the openings that need to be provided in the load bearing structures, because it compromises the load bearing capacity of the wall, so non-structural walls are added in those places where openings are needed to be provided, and other elements are provided with structural walls, and this is usually used in hotel or hostel room construction where identical rooms are need to be constructed for longer lengths. Then double cross wall structure. In this arrangement, a complex system of cross walls are set parallel to both the major axes is adopted, and this helps to use maximum daylight in the structure as shown in the figure. So in single wall you saw that the structural wall is in this direction mainly, while in double cross wall it's running in both the directions, and both directions have non-structural walls and structural walls. And then complex wall structure. In this arrangement, a combination of cellular and cross wall arrangement are followed to meet the purpose of creating various sized spaces within the building. So our answer is double cross wall structure. This is a double cross wall structure. Question number 8. Ontario's Celebration Zone Pavilion in Toronto is an example of load-bearing structure, shell structure, pneumatic structure, or framed structure. So what's a load-bearing structure? In load-bearing structure, load-bearing members are walls. A load-bearing wall or bearing wall is a wall that is an active structural element of a building. That is, it bears the weight of the elements above said wall, resting upon it by conducting its weight to the foundation structure. So a load-bearing wall or bearing wall is the active structural element of a building, and it bears the weight of the elements above the wall. The entire weight of the building is shifted to the wall, which then shifts the weight to the foundation, and the entire building is made up of walls. Shell structures. A shell is a thin curved plate structure which is shaped to transmit applied forces by compressive, tensile, and shear stresses that act in the plane of the surface. Pneumatic structures. Pneumatic structures are membrane structures comprised of the volume of inflated air. They are extremely lightweight structures, and existing internal pressure pre-stresses the enveloping membranes that are subjected to tension and counteracts the external loads. Frame structure. In a frame structure, load-bearing members are beams and columns. A frame structure in any material is one that is made stable by a skeleton that is able to stand itself, a rigid structure without depending on floors or walls to resist deformation. And this is how the Ontario Celebration Zone Pavilion in Toronto looks like. It's located in the east coast of Lake Ontario, Toronto, Canada. The architect was Hariri Pontarini Architects. The area is 1200 meters square. It was built in 2015. The manufacturers of this were Sergei Ferrari. It is built out of air beams joined by a quilted inflated fabric skin, and it's a pneumatic structure made up of PVC. So our answer is pneumatic structure. It's a pneumatic structure. Question number 9. A massive scaffolding structure mounted on a bridge or platform supported by a pair of tar, which normally run back and forth on parallel tracks, is called a massive scaffolding structure. It's that we are talking here about a scaffolding structure which is mounted on a bridge or platform and supported by a pair of towers which normally run back or forth on parallel tracks is called breakers, transom, gantry, or base plate. So what is a raker? Rakers are bracing system that transfer forces from the shoring wall to a more stable zone. Transoms are horizontal load bearing scaffold components for supporting planks. Gantry. Gantry is a bridge like overhead structure with a platform supporting equipment such as crane, signals, or cameras. Base plate. Base plate is mainly used to spread the load onto the sole plates. All uprights or standards or a scaffold are to be mounted on a steel base plate. So rakers, if you can see the image down in the right side corner, you see we have base plate or a sole plate which takes the load. All are mounted on a steel. All uprights or standards or scaffold are mounted on a steel base plate or a sole plate. Then you see the raker. It's the inclined structure that is used to support the wall, shoring wall. Then we don't have transom in this image, but transoms are horizontal load bearing scaffold components for supporting the planks. And then I have added the image of gantry, which is basically that it's put on a parallel platform. It has a trolley motion and it moves. It is used to it's a platform supporting equipment such as cranes, signals, and cameras to move. So our answer is gantry. It's a massive scaffolding structure mounted on a bridge or platform supported by a pair of towers which normally runs back and forth on parallel tracks. So it is called gantry. Question number 10. Dash is a system of providing temporary supports to the party walls of the two buildings where the intermediate building is to be pulled down and rebuilt. Raking shore, flying shore, dead shore, or underpining. So what is raking shore? In raking shore, inclined members, which are known as rakers, they are used to give lateral supports to walls. So this is a wall, and this is a raker which is used to give lateral support to the walls at 45 degrees, and the rakers can vary from 45 to 75 degrees angle. Flying shore. It is a system of providing temporary supports to the party walls of two buildings where the intermediate building is to be pulled down and rebuilt. What happens in flying shore is, for example, there are three buildings and then the building in the middle is to be pulled down. So we provide a flying shore in which the shores do not really touch the ground, but rather there is a horizontal member between the ends of the two buildings which are supported by two shores, and then the building is pulled down. So that is what a flying shore is. And in dead shore, what happens is that for example, in a vertical member like a wall, you need to provide a opening. So dead shore is provided. It's a straight shore which is provided on lower part of a wall, so that it can be opened and an opening can be created, or a defective load bearing area can be rebuilt. And in underpining, it is the process of strengthening the foundation of an existing building or other structure. It is necessary for a variety of reasons. So because original foundation may not be strong or stable enough, so it's a process of uh, strengthening the foundation of an existing building. So our answer is that flying shore is a system of providing temporary supports to the party walls of two buildings where the intermediate building is to be pulled down and rebuilt. Excuse me. Series of prismatic trusses linked together forms planar truss, space frame, portal frames, space truss. Planar truss is one where all the members and nodes lie within a 2D plane. Space frame. Space frames are 3D lattice structures made up from linked pyramids or tetrahedra into 2-layer or 3-layer triangulated framework. Portal frames. Portal frame building comprises a series of transverse frames braced longitudinally. The primary steelwork consists of columns and rafters which form portal frames and bracing. Space truss. Space truss are 3D structures with longitudinal members connected at their ends by hinges assumed to be frictionless. So the question was, a series of prismatic trusses linked together forms. So the answer will be space frame. As you can see, I have added one image of space frame on the top right corner. It's a structure made up of 3D lattice structure made up of different linked pyramids or tetrahedron shape. So the answer is B, space frame. Question number 12. Circumferential hoop stress developed in a dome is compressive in nature, shear, tensile in nature, shear in nature, or both A and B. So as I had explained before, that the analysis of a dome or a shell is concerned with two kinds of stresses: the stresses that act in the meridional direction and the stresses that act in the parallel direction or hoop. So the meridional stresses are compressive forces, while the hoop stresses are compressive forces and tensile forces. So compressive forces occur on top, and we have, so in the hoops we have both compressive forces and tensile forces. So our answer will be both A and B. Circumferential as in circumference, leading with the circumference, or you can say the hoop of the dome. So the circumferential hoop stresses developed in a dome is both compressive and tensile in nature. Question number 13. Golden Gate Bridge in San Francisco is a cable suspended tensile structure, stayed tensile structure, trussed tensile structure, or pneumatic tensile structure. So this is what Golden Gate Bridge looks like. It's located in San Francisco, Marine Country, USA. The total length of the bridge is 2,737 meters. The construction started in 1933. The architects of Golden Gate Bridge are Joseph Strauss, Charles Alton Ellis, and Irving Morrow. And it has a 67-meter of clearance below. It was opened in 1937, and the height of the bridge is 227 meters. So in a cable suspended structure, it is a structure which is supported by cables coming from beams or trusses, which is atop a concrete center column or core. And in stayed tensile structures, the whole mass of the roof and other things are being supported with the stayed cables. The tension members are supported by compressive members, but the major load are carried out by tensile members. Trussed tensile structure. A truss is a structure that consists of members organized into interconnected triangles so that its overall assembly behaves as a single object. Trusses are most commonly used in bridges, roofs, and towers. Pneumatic tensile structures. Pneumatic structures are membrane structures comprised of the volume of inflated air, and they are extremely lightweight structures, and existing internal pressure pre-stresses the enveloping membranes that are subjected to tension, which counteracts the external loads. So our answer is Golden Gate Bridge in San Francisco is a cable suspended tensile structure. As you can see, there is this main compressive members of these bridges, and then we see the cable taking the load of the entire bridge. So it's a cable suspended tensile structure. Question number 14. Which of the following is not a load bearing structure? Great Pyramid, Egypt, Taj Mahal, India, Colosseum, Rome, and La Oceanographics, Spain. So these are the images of the four buildings: Pyramids of Giza in Egypt, Taj Mahal from India, Colosseum Rome, and La Oceanographic in Spain. So it is very evident from the pictures itself, but I would quickly give information about it. So La Oceanographic in Spain is uh, Santiago Calatrava's in the Science and Art City of Valencia, Spain, and it is inspired by Santiago Calatrava's work. It is a shell structure. Taj Mahal is a load-bearing structure made up of load-bearing. It's a load-bearing structure covered entirely in marbles. Pyramids of Giza is also a load-bearing structure, and Colosseum of Rome is also a load-bearing structure. So our answer is La Oceanographic, Spain. La Oceanographic in Valencia, Spain. It is underwater museum, underwater aquarium, and it has a lot of parts. This is one of the buildings of La Oceanographic in Spain. Question number 15. The vertical member of the tubular scaffold is called standard, ledger, transom, or guard rail. Vertical member of the tubular scaffold is called. So, tubular scaffolding consists of galvanized steel pipes that are connected together by couplers and can be erected in virtually any configuration for false work and working scaffolds. Tubular scaffolding system is known by many names, including steel scaffold, tube and clamp scaffold, tube and coupler scaffold, and tube and fitting scaffold. So in the components or parts of a tubular scaffold, as you can see, the horizontal so the horizontal members are called ledgers, and vertical members usually longitudinal horizontal members are called ledgers, and other sides, the ones that parallel to it, are called transoms. Oh. And the vertical members are called standard in tubular scaffolding. So the vertical member of the tubular scaffold is called a standard. Question number 16. Barrel vault is basically a twisted structure, geodesic dome, tensile structure, or a compressive structure. So barrel vault is also known as tunnel vault, wagon head vault. It is an architectural element formed by the extrusion of a single curve along a given distance. The curves are typically circular in shape, and it leads to creating a semi-cylindrical appearance of the total design. A barrel vault is effectively a series of arches placed one after the another to create a tunnel. Barrel vaults were not exclusive to the Romans but were utilized by the ancient Egyptians and the Etruscans also. And they are compression only structures, and they take the familiar form of walls, arches, shells, and grid shells. So the answer is a barrel vault is a compressive structure. They have high compressive strength, and they have been used as compressive structures throughout the history of architecture. Question 17. Which of the following is an example of anti-clastic tensile structure? Renault Center, Swindon, UK, Tokyo Dome, Clifton Suspension Bridge in Bristol, Gallery of Sky Song at Arizona State University campus. So, tensile surfaces, that is surfaces which carry only tension and no compression or bending, rely on double curvature for their stability. And the stability is provided by the opposition of the two curvature which enable the surface to be tensioned without losing its form. Tensioning the surface reduces its elasticity and so its tendency to deform under load. And the curvature itself means that the surface will deform less for any given extension. Anticlastic surfaces are those in which the centers of curvature are located on opposing sides of the surface. This is commonly described as a saddle shape. So anticlastic surfaces are basically curved surfaces in which the centers of curvature. So there is in this saddle form in the image you see on the right hand side, there is this curve and then there is this curve. So there are two curves over here. There is one curve which is going like this and the other curve that is going like this. It is like a saddle shape. Saddle shape as in saddle is put on a horse on which people sit. So it's like that shape, that it is curved like this and it is also curved like this. So the center of these curvatures are located on opposing sides of the surface, in the sense that this curvature, the center of this curvature would be somewhere here and center of this curvature would be somewhere here. So they are located on opposite sides of the surface, which creates an anticlastic surface. Coming to the four buildings that were mentioned in the question: Renault Center, Sweden; Clifton Suspension Bridge in Bristol; Tokyo Dome and Gallery of Sky Sound in Arizona. So Tokyo Dome is a pneumatic structure which is clear. Clifton Suspension Bridge is a suspension bridge, cable suspended bridge. Renault Center, Sweden is a cable stayed structure. And Gallery of Sky Sound, you see we have tensile, it's a tensile structure for sure, and then we see the different curves that are being created here, in which you can see that the center of the curves that are in this structure, they are on the opposite sides, which means this is an anticlastic structure. So the answer is Gallery of Sky Sound at Arizona State University campus is an example of anticlastic tensile structure. This is it for today. If anybody has any questions, you can ask. I will try to answer it best to my capacity. In case I will not be able to answer your questions, I would answer it in the next session. If anybody has any questions regarding this session, please ask away your question. You're welcome. If nobody has any questions, we can end the session. Or if you have any other questions regarding this session or any of the topic covered. I am ending the session because there are no questions from anyone. Uh, have a good evening, everybody. Thank you.